welcome, Philipp. I thank you. We already know you, so if you, just let's make it start.
No introduction necessary. Yeah, but still, my name is Philipp. I'm a software engineer here at Celebrate Company. This is my Twitter handle if you want to follow me. And that's my team on the left side, or right side for you. So let's talk about font metrics. Now, I don't know if you have heard about font metrics before. I certainly hadn't heard about it before I kind of ran into some of the issues that I will describe. But I hope that this talk will kind of help you understand what it's all about and maybe also see why it could benefit also you looking a bit more into font metrics and why it makes sense to understand what this topic is all about. So let's consider the following example. You are part of a product team, and there's a designer on your team, and he comes to you with a simple task. They want you to build this dialogue that we see in the top right corner. Looks fairly simple, has a headline, has a paragraph, has a button. And your designer, I mean, he's very nitpicky, he's very specific, so he tells you exactly all the details that you need to implement. So the font, in this case, it's called Palanquin. Then they tell you about the font sizes, about the line heights, about the colors, and also very important about the vertical rhythm that they want to create in this design. So they tell you about all the spacings and about the exact pixel values that they want to have. So around the dialog, the padding should be exactly 32 pixels, right up until the H character, so really up until the capital letters of the font. And then between the headline and the paragraph, and also between the paragraph and the button, there should be a spacing of 16 pixels. Very important that this is exactly the same number. And then inside the button, the spacing in the top and the bottom, the padding should be 16 pixels again. And on the left and the right, it should be 24 pixels. Still, fairly simple UI to build. So you go off, do your front-end magic, build the dialogue, are proud of what you built, and you come back to the designer with this. Now, who of you can tell me what looks wrong here? Margin top, okay. It's not centered. What is not centered?
Vertically and horizontally. I won't move. Maybe I'm sitting well, at least horizontally.
Yeah.
Vertically is not
Yeah.
centered.
Yeah. So as especially if you look at the button, the text in the button, it doesn't appear to be centered. Although we use perfect centering in CSS, right? Also, your designer is not happy about this, right? They come to you your vertical rhythm, it's all over the place. I mean, can't you follow what I tell you? It gave you all the specifications. I mean, look in the top, it should be 32 pixels and not 38. And between the headline and the paragraph, it should be 16 pixels and not 25. And also between the paragraph and the button, it should again be 16, the same number, and not something else like 22. And I mean, in the button, don't you know CSS? Just center the goddamn text in the button, right? I mean, it can't be that hard. So, you're a bit bummed about this, what's going on? And you compare your result in the browser to the specification from the designer. And yeah, he's or she is correct, right? The spacings are off. I mean, it's clearly off. The question is just why? What's going on? So let's debug this a bit, and let's add some borders, because we all like borders. And we can already see on the right side that, well, the spacing values that you use, like the paddings and the margins, are the correct values. But, I mean, maybe you can already see what's going on, right? Inside of all of these boxes, above the text and below the text, there is some extra white space, which, of course, if you measure right to the baseline or to the capital letters, it will add up to quite some pixels in the end. So where does this magic white space come from, and why do our designers have to be so picky about this? But of course, we want to please the designer. We want to have a beautiful dialogue where everything is perfectly centered. So how do we fix it, right? Okay, and I'll give it away, sorry. I wanted to ask you. Negative margins, that's the best solution that I found, but maybe you have a different idea. What would your instinct say? How would you get rid of this white space, this excess white space? Maybe some idea, somebody. Line height, yeah, that's a good one. Vertical alignment, okay. So line height actually goes in the right direction. We will talk a bit about line height later on. But the best solution that I found is negative margins. So with negative margins, we can create this. So we just remove all this excess white space above and below each individual text. And by removing all of that space, we create exactly what the designer wanted. The button is then perfectly centered, and all the spacings, they line up correctly. So how do we get there? As I said, we need to use negative margins. One way to do it is what you can see on the right. It's some special pseudo elements to just avoid margin collapsing, but that's besides the point. The important bit is the margin bottom and the margin top. And the big question is, which numbers should we put in there? Like, what's the number for the negative margin to get rid of this extra space? And of course, we could do some guessing, we could do some trial and error, we could try out different numbers, but there would be a different number for each different text. And we are engineers after all, right? So we want to know the deterministic answer. We want to know, how do we get to these numbers? And the answer for these numbers is in the metrics. Now, what do I mean when I talk about metrics, or specifically font metrics? This is a little illustration of some of the metrics that a font typically defines. And these metrics, they are defined by the designer of this font, by the designer of this typeface. They think about their typeface a lot, about the sizes of all the characters, and they define these metrics. And there's also different tools that allow us to extract these metrics from the font files. This is one of them. This tool is called FontForge. And the font that we are looking at, again, is Palanquin. And here you see the metrics for this font. And there's also JavaScript libraries that help you to extract those metrics. But now, before we dig into these metrics and how we can kind of derive the negative margins from them, we first need to build up some more foundational knowledge. So let's answer this seemingly simple question together first. If I set the font family to Palanquin, the font size to 50 pixel, and the line height to normal, which is the default value in the browser if you don't use a reset, how big is the text going to be? What do you think? 60, OK. Any other guesses? I think we all would hope it's going to be 50, right? The answer is 90.5. Who would have thought, right? I mean, a bit crazy. It's actually, to be super correct, it's 90.55. The question is just, how do we get to this number? How do we know how tall this text is going to be? Again, the answer is in the metrics. So we're going to look at 3 different metrics that will help us to calculate this number based on the values we had in the beginning, on the font size, and the line height. So the first metric we need to look at is the so-called M size. And the M size is basically sort of a reference box around each character. So each character is positioned inside of this reference box, and all the other metrics of the font are relative to the M size. In this case, the M size is set to 1000. That's the value that the typeface designer picked for this specific typeface, and every character is positioned in such an M box of 1000. It's a unitless number because fonts are vector-based, right? They need to scale to any kind of size, like behind me, like very big letters, and also on your screen, smaller letters, like a SVG, basically, right? So there's no pixels or millimeters or inches here. It's just unitless numbers. So that's the M size. And then we have the HHead Ascent and the HHead Descent. And those two are what the operating system uses to know how much space to reserve in the top and the bottom of the text to avoid the text bumping into other different things. Because there might be some characters that are taller than a typical uppercase character, like the German umlaut, right? If you have an uppercase character with an umlaut on top, it's going to be taller. So the browser needs to, or the operating system wants to reserve some space so that your text doesn't bump into any other elements. And the typeface designer, in this case, chose a value for the ascent, so from the baseline to the top of 1320, and in the bottom, they chose 491. It is a negative, what is it, index? No, prefix, I guess. And for the other number, because it goes from the baseline to the bottom, and the baseline is basically, if you think about a coordinate system, it's just y0. And yeah, so we are basically interested in the height of this whole thing. So here we see all of these 3 metrics together, and we are interested in the height of this box. I just called it the HHead box height That's not actually a term that people use, but I just made it up because it made sense. And we can calculate the height of this box pretty easily by summing up the ascent and the descent. And if we sum up those two numbers, again forgetting about the minus, then we arrive at 1,811. So if we just think in these typography metrics, this is the height of this box, so the height of the text. And now we come back to this text of line height normal, which, as we know, has a height of 90.55 in the browser if we set the font size to 50. Now we kind of align this, and you can already start to see, yeah, there's some similarity here. So the baseline lines up quite nicely. Also the uppercase character lines up nicely. And now we set the font size to 50. And when we set the font size to 50, what we are actually doing is that we are saying that 50 pixel now equals this M size of 1000. So the M size is kind of like a knob that controls how big or how small the text is going to be. So we are just saying this is now equal. Now we know the height of the HHead box, we know the M size, we know the font size, and we are looking for the height of the text. So there's just one variable left in this fairly simple formula. Height divided by the font size must be the same as the HHead box height divided by the M size. And now we fill in the values of the ascent and the descent, we calculate the box height, we restructure the formula, and voila, we arrive at 90.55 pixel. So this is the math that the browser or the operating system, I don't really know who does it under the hood. We just don't see it, but this is actually what's going on. The little downside here is that it's a fixed pixel value. So as soon as we change the font size, we need to do this math over again. But we can do a little trick. We can just swap out the font size for 1 EM to just have it relative to whatever font size is set for this element. We do the same formula, the same math, except now we arrive at 1.811 EM. So now this value is relative to whatever font size we set for the current element. And this tells us that the height of the text will always be 1.811 times the font size. Crazy, I know. Yeah, so that's the basic math. And what we also learned from this is that the line height of normal for this specific font actually equals to a line height of 1.811. And if you think about it, this tells you that line height normal means something different for every font because it's relative or it's specific to this font's metrics. So that's why line height normal sometimes is a bit weird if you try to use it. Okay, so now we know how to calculate the height of a text looking at the font metrics. And now let's do the same thing for the cap height. What is the cap height? It's another of these font metrics, and it's just the height of a capital letter. And that's exactly what our designer wants us to do, right? The height of the text should just be the height of one capital letter, from the baseline to the capital letter to the cap height. For this specific font, again, for Palanquin, it's 680. So what we want to do now, in the very top, we see what the browser typically renders, right? It renders the text, or the height of the text goes from the HHead descender to the very top to the HHead ascender. What we actually want is just from the baseline to the cap height. We don't want the height of the text to be more than this. We still want it to render outside of this box. We still want to see like the little descenders in the bottom, but it shouldn't take up more space than just this height. So what we need to subtract using, again, negative margins, is these two red areas that we see in the bottom. What we essentially want to do is this. So we just want to cut off the space in the top and cut off the space in the bottom so that the height the element takes up is just the height of the capital letter. So these are the two areas that we need to cut off. First, we need to calculate the height of these two areas. The height of the top one is fairly easy to calculate. It's just the ascent minus the cap size. And we arrive at a height of 640. The sliced bottom is even simpler because it's really, again, just the height of the descent, which is 491. And now we do the exact same math as we did earlier for calculating the height of the text. So again, we say 1 EM now equals to the M size of 1000. We know the height of the sliced top. We want to get the height of the sliced top in the browser. We have the same formula. We fill in the values, we restructure the formula, and now we arrive at a slice top height of 0.64 EM, meaning the slice in the top that we want to cut out is always going to be 0.64 times the font size. And the same math, of course, goes for the slice in the bottom. Same formula, same math, different value, of course, because the slice bottom is a bit smaller. And the slice bottom is always going to be 0.491 times the font size. And now with these two values, we can go back to CSS. And we can add these values in this little snippet of negative margins. And voila, all of a sudden, this box nicely aligns with the height of a capital letter. It's not taller anymore. It's not smaller. It's exactly what we want. The problem is just that this now only works when the line height is normal, not when the line height is set to some other value. The problem is, in this dialog that we looked at earlier, no line height is set to normal. They're all set to some specific values. So let's see how we can kind of work around this issue. So what about other line heights than normal? Because, for example, if we just set the line height to 1.4 and we do the exact same math, we're going to have too much of negative margin, right? We're going to shrink the box too far down. It's going to be too small. And there's one thing to remember about line height. So for line height in CSS, it always adds half of the desired distance between the lines on top and the other half in the bottom of each line. And you can see that visualized here in the bottom. So we want to have this specific distance between the lines. And what the browser is doing is adding half of this distance on top of each line and half of the distance on the bottom of each line, which leads to the distance between lines to be exactly what we want. But there's also some extra distance or extra white space on the top of the first line and in the bottom of the last line. And this is what we need to consider when we work around this issue with line height normal. So if we look at two paragraphs with the same text, the left one has line height normal, which for the font we are using, again, equals to 1.811. And on the right side, we have a text with a line height of 1.4. Now we observe two things. The first thing is that, of course, the distance between the lines is smaller on the right side. The second thing we observe is that the distance on the top and in the very bottom is also smaller on the line height. Of course, this distance grows and shrinks with the line height. And now the idea is to re-increase this distance in the top and in the bottom back to what it was when we had line height normal, but to keep the distance between the lines the same. So the distance between the lines stays at 1.4, but the area above and the area in the bottom, we kind of increase it back up as if we would be using line height normal. Why? Because then the math we did earlier for line height normal will work again. How do we calculate the height of this green area? It's pretty simple. It's the normal line height of 1.811 minus the desired line height, which depends on what we want to use. In this case 1.4, which results in 0.411. And then we have to add just half of it in the top and half of it in the bottom, and then we're done. I know this was a bit fast. And it's also not crazy important to understand these details, because we just look at the result now. So on the left, we see the original dialog as we had it, and on the right, we see the result. And to prove you that this actually works in the browser, I will show you a CodePen. So, come on. So, left side is the original dialog, and the right side is the dialog with my fixes applied. And if we look at what the CSS is actually doing, it is here. So we have our three values that we calculated earlier, the delta above, 0.64, the delta below, that's the value for the negative margins. Then we also have the normal line height here. And then we have some negative margins, which do the calculations that I explained to you earlier. And as you can see on the right side, it lines up perfectly. And also I added this little animation just so we see it. So this now makes all the spacings look correct and work nicely. So our designer's happy. We are kind of happy with this, I know. But yeah, maybe now after this, you feel like this. There was a lot of numbers, lots of math. I talked way too fast, right? So it's all a bit maybe too complex. So wouldn't it be nice if the browser could do all of this for us? Now I have good news and I have bad news. The bad news is there is no CSS feature for this, and there is no browser which supports this. The good news is Not yet. There is a CSS draft for this. It's going to be called the text box trim property. Well, it will potentially be called like that because it's still a draft. They are still working on it. There is no browser supporting this yet, except for not Chrome. Safari technology preview. Who would have thought? And here on the left side, we can see it actually looks really nice. And it is just these 2 lines of code that make everything work. And I will prove it to you. I comment these 2 lines of code out, and the dialog will jump up to its original thing. If I comment them back in, it will shrink back down. And actually, it's a bit more accurate than my math, I guess, because it is like 1 pixel less. And if I measured everything with my measuring tool, and it like lines up really perfectly. Well, not now because I'm zoomed. But believe me, I measured it. It works really, really nicely now. So going back to the slides. So yeah, it's really just these 2 lines of code that make it work. And this is super flexible. This allows us to really define what we want to cut off. In this case, we're saying we want to go from the cap height to the alphabetic baseline. I don't know why they don't just say baseline. Don't ask me. Maybe, hopefully, they will still change it. And I know we have people from Chrome DevTools. It would be cool to have DevTools for this in the future, so we can like really visually select what we want to like snap to or like cut out. That would be super cool. With that, this feature will hopefully come eventually. When it arrives, you will know why we needed it, and you will hopefully have understood a bit more about the math behind it and about why it's useful. So thank you, and I'm happy to answer your questions.